All right, section 3.3, example number 7, the last example for this section of application of system of linear equations. So, talking about quilting now. Not one of my hobbies, but maybe somebody else is out there. So, let's talk about Catherine here. She has a quilting shop and makes 3 kinds of quilts. The Lone Star quilts, the bandana quilt, orderly, and the log cabin quilt from the barn. Okay, so, and we have some descriptors from each of these. So telling us about each Lone Star quilt requires 8 hours of piecework, 4 hours of machine quilting, and 2 hours of finishing. The bandana quilt requires 2 hours of piecework, 2 hours of machine quilt, and 2 hours of finishing. And each log quilt requires 10 hours of piecework, 5 hours of machine quilting, and 2 hours of finishing. And if that wasn't enough information, Catherine, she allocates 74 hours for piecework, 24 hours for machine, and 24 hours for finishing quilts each month. That's all she has, you guys, so don't try to do any more. How many of each type of quilt should be made each month if all available time must be used? So we got to maximize these times. How many of each one then? Okay, so basically we're just trying to find out like how many long story quilts, how many brain bandanas, and how many log cabin quilts. So let's go ahead and just jot that down there. That's what we're trying to find. So X is the number of Lone Star, right? And then we'll let Y equal the number of bandana quilts. And then Z is going to be the number of cabin quilts. Cool, so that's what we're trying to find. So again, we're going to have a system of linear equations with 3 variables this time. And I want you to check this out here. So there are like 3 categories, right? There's the category for piecework, there's the machine, and then there's finishing. As you can tell, it does that for all of them, right? There's piecework, the machine, and finishing. It does that for all 3 of them here. Piecework, machine, and finishing. So I bring that up because that's how we're going to create our 3 system of equations. So check us out. If we look at just the piecework, look at there's 8 hours of the Lone Star, right? Plus 2 hours of the bandana. Oops, that should be Y. And 10 hours of the piecework for cabin. Now, we know that if you were to take the piecework of all 3 of them, she only allocates 74 hours. So that means we're going to say there has to be 74 hours. And that's what she says, that we have to use all of the hours, but it has to be distributed between these factors here, where it takes 8 hours to make one of these guys. It takes 2 hours to make one of those and 10 hours for that guy. Okay. Now we're going to do the same thing for the machine quilting, right? So let's see, for the Lone Star, it takes 4 hours for the machine quilting. This guy takes 2 hours, and this one here takes 5 hours. And she allocates 42 hours. Okay, last but not least, let's do the finishing. So 2 hours for the finishing, here 2 hours for the finishing, and 2 hours again for the finishing. And that's for 24 hours. Great, well, this now becomes a traditional, what we call a 3 variable system of equation. So we just got to go through the laborious work now of figuring this out. So let's just maybe work with the first 2 equations, okay? And I think what I want to do is I want to multiply, maybe I'm going to multiply this bottom equation right here by -1. Okay, so I want to multiply this side by -1 and that side by -1. So let me drop down my first equation first. Okay, so 8x plus 2y plus 10z equals 74. Now I'm going to multiply everything by -1, or just change all the signs. -4x minus 2y minus 5z equals a -42. Okay, and we can see what happens here. The y's will cancel. We have 4x. We have a 5z. And then we have 32. Great, so that's one of our equations that we're going to do there. Then let's take the bottom two equations now. Okay, so I'm going to take these two guys. I'm just going to go and erase this so we're not confused now. I'm going to erase this guy here. Great, so now I'm going to go ahead and take these two now down here. And I think I'm going to do the same thing actually. I'm going to use the same, how I multiply this by -1. I'm going to use that same one right there. I'm just going to go ahead and see what I get right there then. Okay, so that means I'm going to take this guy but multiply it all by -1. So -4x minus 2y minus 5z equals 42. And then drop down my last equation. 2x plus 2y plus 2z equals 24. Add it all together, I get a -2x, y's cancel out, a -3z. Oh, and this was supposed to be a -42 right there, right? Yes. So that's going to give us a -18. Sweet. So now we have our two equations that only had two variables, right? That's what we want. So now we can go ahead now and solve now. So I'm going to come over here. I'm going to rewrite those two equations. Cool beans. So I think I'll just multiply this bottom equation right here by -2. Just multiply everything by -2. So that means this now becomes a positive 4x. This right here becomes a positive 6z. And this right here becomes a positive 36. Okay, so now if I add these guys together, we get, let's see, 8x, 5 and, wait a minute, something was supposed to cancel. Oh, snaps, I wanted this to actually, these to cancel out, so I should have multiplied by a positive 2. Oh, snappers. Okay, so let's just let's just multiply that by a positive 2 there. Let's try that right there, actually. So positive 2, so that means it's a -4x, a positive, or a -6z, okay, so now if you add those together, 4x minus 4x is 0, 5z minus 6z is a -z, and 32 minus 36 is a -4. So divide both sides by -1, so z equals 4. All right, cool beans. All right, so let's just maybe use this guy right here. 4x plus 5 times z, which is 4, equals 32. That's 20 right there, right? So if I subtract 20 from both sides, I get 12. Divide both sides by 4, and I get 3. And then last but not least, I can solve for y by just taking one of my other equations up there, which I'll just take this one right here, which was 2x plus 2y plus 2z is equal to 24, and just plug in my x and my z. So 2 times 3 plus 2y plus 2 times z, which is 4, is equal to 24. So that's 6 plus 2y plus 8 equals 24. Add those guys together. Subtract 14 from both sides. 5 by 2, I get 5. Cool beans. So my answer now is, how many long story quilts can we actually make? That means we can make 3 of those guys. How many bandana ones? We can make 5 of those bad boys. And how many of the cabin ones? What was that? I think that was 4. We can make 4.